The next question is, derive an expression for the torque acting on an electric dipole which is held in a uniform electric field when the axis of the dipole makes an angle theta with the electric field. This question was asked in 2019 by CBSE, and this was carried 2 mark. So, okay, we can see how we can start the answer. So we have to write one sentence like this. Consider an electric dipole of dipole moment P is equal to Q2A placed in a uniform electric field. Then we can draw the uniform electric field. You studied that uniform electric field representing parallel lines, correct? So there we are going to place one electric dipole. You know that electric dipole consists of 2 identical charges but opposite charges. So plus Q and minus Q I placed here, and separation between them is 2A, and the angle made with the electric field is theta. So you can see that much here. What we do next is, we want to write how much force will be acting on the charge when it is placed in a uniform electric field. For that, we have to write one equation that we already know. That is, electric field is equal to force upon charge. Correct? You studied this one, F by Q. Then do a cross multiplication. Then you will get what is F is equal to. So F is equal to QE. So F is equal to QE is the charge, the force acting on the charge plus Q, that is towards or along the direction of electric field, and F is equal to minus QE is the force acting on the charge minus Q, which is against the direction of electric field. So here you can see that there are 2 equal forces acting on 2 different charges. So what will be the resultant that we have to write? Before that one, we have to talk about the perpendicular distance. So perpendicular, why we want to talk about the perpendicular distance? Because we have to write the torque. You know that the equation for torque is force into perpendicular distance, correct? So for that we are going to write one equation here. So what equation is, consider this is like a triangle formed here. So perpendicular distance we can draw here. That is perpendicular to the direction of this electric field. So that I will draw now. And I want to introduce the equation also. So what equation we will use here to get it? We have option to write sine theta here. So because in this triangle I drew here the line, perpendicular line. Let us write H is the perpendicular height right now. Okay, so we can use sine theta here. You know that sine theta is opposite side divided by hypotenuse. Here the opposite side is H and hypotenuse here is 2A, because hypotenuse decided by looking into side opposite to 90 degree. So from there you can write that after cross multiplication, H is equal to 2A sine theta. Why we need this one? Because when we got to write the torque, we need force into perpendicular distance. There we will use. So here is the equation for torque now. Torque is equal to force into perpendicular distance. So I am writing the equation first, then I will replace the word with the symbols. So equation symbol for the torque is tau, and force we already defined what is force here, F is equal to QE, and perpendicular distance also we defined here 2A sine theta, correct? So I completed my part. Now what I do next is identify the electric dipole moment here. You studied that electric dipole moment P is equal to Q2A. I identified and wrote together. So Q2A E sin theta. And next we are going to replace Q2A with the electric dipole moment. Q is equal to, in the place of that, Q2A is equal to P. So the final expression for torque produced is torque is equal to PE sin theta. This is the expression for torque produced, and usually this question carries 2 marks. And in some question paper we can see that some extended small questions. Question like this one, when will be the torque maximum? When will be the torque minimum? Some other question paper we can see that which one will be the stable equilibrium, which one will be the unstable equilibrium. First we can see in terms of theta. If the theta is 0, you can see that sin theta is equal to sin 0 is equal to 0. So torque is equal to 0 because PE into 0. And when the angle is 90 degree, that is the dipole is perpendicular to the electric field, theta is equal to 90 degree. You know that this is the highest value of sin theta, right? Sin 90 is equal to 1. So the maximum torque will be equal to 1. So sin theta is equal to 1. So torque is equal to PE. Okay. In this way, you can answer it and you will get full mark, that is 2 mark. Okay students, thank you for watching. See you. Bye bye.